masking and binocular rivalry. What we just talked about may seem a bit abstract. Let's see how they work with some examples. To look for the NCC, researchers may make use of a technique called backward masking. Say if we present a stimulus called a target, very briefly, say only for 50 milliseconds, to be followed quickly by a jarring pattern called a pattern mask, like this. So here, the target is a rhombus with one corner missing. The mask is a pattern made of some hashtag signs. Let's say the subject's task is to identify whether it is the left corner or the right corner of the rhombus that is missing. Given that the mask is presented so quickly afterwards, people may fail to do the task. We can unmask the stimulus by removing the mask altogether, or we can increase the SOA, that is, the stimulus onset asynchrony. This refers to the temporal distance between the onsets of the target and mask. In other words, we can present the mask much later, say a whole second later. In that case, people should see the stimulus without problem. So, comparing the unmasked versus masked conditions, we can find the NCC for the perception of the target, and indeed some researchers have done that. Now then, in the unmasked condition in which subjects unconsciously see the target, do you think it would be better if there was no mask at all, or that there is a mask with a long SOA? The consideration is, if there is no mask at all, there would be a big stimulus confound. The masked and unmasked conditions may differ rather too much. But even if we keep the mask in both conditions, changing the SOA to allow the target to be consciously seen in the unmasked condition, the really hard-nosed critic may still say there is a small stimulus confound. That is, the SOA differs. The two conditions are not entirely matched physically. Now then, for fMRI, where the signal is sluggish, mostly it isn't that big of a problem. That is, when there is a confound, it is not the end of the world. We should think about how this would affect our results. The experiments should not be written off entirely. We just have to interpret the results while being mindful of the confounds. But there is a kind of experimental setup to get around this problem of a small stimulus confound, if one is a perfectionist about it. The phenomenon is called binocular rivalry. This is based on the fact that if we present different things to the two eyes, when set up correctly, we don't see the fusion of the two images merged together. Instead, we see one image at a time for a few seconds, and then spontaneously, our percept switches to the other image and back and forth. So let's say we present some red grading to the left eye and some blue grading of a different orientation to the right eye, like what we show here in this figure. What we consciously see will not be some red and blue stuff merged together or overlaid on top of each other. Instead, we see the red grading pattern for a few seconds and then the blue grading pattern for a few seconds. It will switch automatically, regardless of what we want to see, like a movie. Kind of cool. Now then, remember that your left eye doesn't just see things in the left visual field. If you cover your right eye, you'll see that your left eye alone can see both the left and right visual fields. So, to make sure different images are presented to the two different eyes, you need some goggles and mirrors or a stereoscope. Although it's a bit tedious to set up, binocular rivalry is very popular among consciousness researchers. That's because in binocular rivalry, the physical stimuli stay the same. Our conscious percept changes spontaneously back and forth between the two images without the stimulus changing. If we can track the switches in perception and find out what brain activity follows that, we can identify the NCC with no stimulus confound at all. That is, let's say we find some neurons in the brain, for example in visual area V4, that fire whenever people see the blue but not the red grading pattern under binocular rivalry. We can be sure that this is not because we are comparing conditions where the physical stimulus differed. It's the same pair of red and blue grading images presented to the two eyes all along. The neurons that fire when we see blue but not red must be firing because of what goes on in the mind, not in the stimulus. This sounds great. Or does it, really? If you think about this in terms of confounds, Is Binocular Rivalry really as good as some people think?